in today's class, we are going to study about converse, contrapositive, and inverse. In previous class, we studied about what are the different types of laws, and today we are going to see the definition of converse, contrapositive, and inverse. Let P comma Q be two propositions, then the converse, contrapositive, and inverse are defined as follows. Now, what will be the converse of P? P implies Q. The converse will be Q implies P. The contrapositive, that is, if P implies Q, is what contrapositive is written as negation Q implies negation P. And the inverse. So, what is the inverse of Q? P implies Q. That will be in negation P implies negation Q. I hope I'm clear with all the three: converse, contrapositive, and inverse. And we'll quickly look into the truth table of the following these things. That is converse, contrapositive, and inverse. So let us make a truth table. That is for column P, Q, P implies Q, and then we'll talk about Q implies P. This is converse. We'll talk about contrapositive. That is negation P implies negation Q. And then negation Q implies negation P. Do one thing, make negation P, negation Q columns also, and then make P and Q columns. So what will these be? This will be true, 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 false, false, true, false, false. Now, what will be the negation P values? It will be false, false, true, true. And negation Q is opposite of these. That is false, true, false, and false. Now, what is P implies Q? P implies Q. So that this column will be like P implies Q. True, true will be true. True, false will be true. False, true will be false. False and false gives you a truth statement. Okay. Now, talking about Q implies P, that is Q implies P. That is true into true gives you true. False into true gives you false into true gives you true. And then this gives you false, and then this gives you true. Now, coming to negation P, like these both. This is true, true, false, true. And coming to negation Q and negation P, this will be true, false, true, and true. Okay. We just made a truth table based on these two columns itself. That is true, 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 false, false, true, and false, false. We just took negation P, negation Q, then P implies Q, P implies Q, and then we took contrapositive, converse, and inverse. Now, everyone observe contrapositive, converse, and inverse, all the truth values and false values are same. That is converse, contrapositive, and inverse. See, true, 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 true. Okay, it is. This is different. Inverse is different, but contrapositive and once again, converse and inverse, these both values are same for these truth values. Okay. Shall we move on to the next problem? Yeah. Now we will look into from the previous table. What is that we have observed? P implies Q is logically equivalent to negation Q implies negation P. Okay. Now we will move on to the second, the other problem. That is, if P is biconditional to Q, then that is that logically equivalent to P or Q implies P and Q. Now, by using all these P and Q values, we have to tell whether this is biconditional to the logic. This is logically equivalent. This is biconditional, and this is implies. That is conditional. So now quickly look into the truth table. So what is that we can make? First column is P, and then Q, then P implies Q, and then P or Q, P and Q, all the values, like all the values that whatever we have over here. And then we'll have P or Q implies P and Q, the right hand side ones. Okay. Now, what will be the P and Q values? Same, true, 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 false, false, true, false, false. Now the conditional, that is implication form. What is that? You'll have true, false, false, true. If you have one false, the entire statement will be false. So P or Q, this will be true, true, true and false. If both are false, the or condition is satisfied. Now coming to AND, if you have even one F, the entire condition will be F. That is true, false, false and false. Make sure that you are perfect with the definitions of those conditional, biconditional and all. This is P or Q, that is this implies this. So this will be true, false, false, true. Am I clear till here? Now what is that we have to see? We have to see whether P biconditionally implies P or Q. That is logically equivalent. What is logically equivalent? It should be equal. So now from third and sixth column, that is this column, the third column and sixth column. That is what we want. Third and sixth column. Are they equal? See third and sixth column. What is the third column? You have true, false, false, true. What is the sixth one? True, false, false, true. What are they asking? This is conditional. If P implies Q, is P or Q implies P and Q? Yes, because we got these both as same. Hence, we can tell that. Hence, P implies Q is logically equivalent to P or Q implies P and Q. Am I clear? Now, this is biconditional only. Now we'll see how to define this biconditional. Yes. Yeah, okay. Now we'll see how to define this biconditional. Okay. Now consider, take the part, this part B, that is we are talking about the biconditional. Consider P is biconditional to Q. So what is biconditional? We have P is biconditional to Q. This is logically equivalent to P implies Q and Q implies P. That is, this is the formula of logical equivalence. Whenever P is biconditional, P implies Q and Q implies P. So how can we write this? P implies Q is negation of P or Q, and this can be written as negation Q or P. Since P implies Q is equivalent to negation P or Q. Okay, this is from the logical equivalence thing. And this is equivalent to now as we have negation, this is in the form of distributive law. So by distributive property, what is that you can write? First make this symbol, like first make utilized with this symbol. You'll have negation P or Q and negation Q or P. So now write negation P or Q and negation Q. We are just taking this with this one. This is finished. Or you'll have negation P or Q and P. Okay, we are just making use of distributive property. Next, you can write, since by making use of distributive property or distributive law. Now, in the next step, what is that we have to do? We can, by associative or commutative, if what is commutative, U into V gives you V into U. So we have to just reverse this and write. So how is that you can write? Negation Q and negation P or Q. This is by commutative law. Or same thing, this comes first, P and negation P or Q. Okay, this since by commutative law. Okay, now coming to the next step, what is that you have to do? As you have negation Q and negation P, see here you have OR. So now we have to distribute even this. So what is that? You'll have negation Q. I'll write it over here. This is equivalent to negation Q and negation P. This is one thing. Or that is, and with by respective to distributive law, we are using this. Or negation Q and Q. Okay, this is finished. Now I'm writing this. Or again, you have to distribute this one. P and negation P. This is finished. Or P and Q. Okay, since this is by distributive law. What is that we are doing? We are just distributing and writing it. So this is by distributive law. Now coming to the next step, you know what is negation P and Q and P and negation P. So now you just write negation P or Q or V. I'll tell you why did we write this. Or F and F or. This is what you have to write. This one. F or P and Q. Now everyone see here. We know by the De Morgan's law, negation Q and Q gives you F. Negation P and P gives you F. So in place of negation P and P, we have F. In place of P and negation P, we have F. And there is another law, negation Q and negation P can be written as negation of P or Q. Okay? By using complementary law. This is by complementary law. Complement law. Okay? This is by complement law. And this is by De Morgan's law. By De Morgan's law. Okay, this is what we got after we took De Morgan's law and complement law. So now we can write this as, this is equivalent to negation of P or Q or P and Q. Like whenever you have negation of P and Q or F, it is like identity. By identity law, you'll have negation of P or Q or P and Q. So this is equivalent to P or Q implies P and Q. Am I clear till here? This is what the solution is. Hence proof. So by based on, if you wanted to solve these kind of questions, you have to be perfect with different types of laws. Am I clear? Next, we'll just look into truth tables. There are few truth tables. The first one tells construct the truth table for P or negation Q implies P. The second one is negation P and Q or R implies negation P. So first we'll just solve the first one. To solve the first one, what is that? First we have to take P, Q, and what are they talking about? That is talking about negation Q. So you don't have to take negation P over here. So take negation Q and then take this one directly, P or negation Q. This is P or negation Q implies P. Okay. So write down the truth tables. That is true, 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 false, false, true, false, false. So what is the negation of Q? This will become false. This is true. This is false. This is true. Now P or Q is, you already know by disjunction property. I'm just writing it directly. You'll have true, 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 and false. This is what the first condition is. That is, they just asked you to find the value of this. So what is that we got? We got true, 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 and false. Okay, now we'll solve the second one. Yeah, the second one, what are all the columns that you have to make? You have to make P, you got to make Q, you got to make R. See, now we have, till now we just studied about P and Q. Now there is another this thing that it is R. The other parameter is R. So you got to make 3 columns for P, Q, R itself, and then you'll be having P and Q. Then negation of that one. You'll have negation of P and Q, and then you'll have negation of P and Q into R, that is OR, and then write the entire thing, negation P, that this is negation of the end, the negation comes outside, negation of, so negation of P and Q or R implies negation P. So what are the columns that you have to make? One is P, one is Q, one is R, and rest of the columns are based on the question. As we have three parameters over here, now you got to write the truth table. So how do you write the truth tables? In the before one, we just had 2 truths and 2 false. Here you got to make use of 4 truths and 4 false. That is true, 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 true. 4 truths and 4 false. That is F, F, F and F. Why are we making use of 4? Because we have P, Q, R over here. Earlier we just had P and Q. So we just took true, true and false, false. Now as we are having P, Q, R over here, you got to make use of 4 truths and 4 false. So what will be the Q column? Q column will be alternate, like 2 truths and 2 false. That is true, true, false, false. Again true, true, false, false. What will be R? Alternatively true and false. So true, false, true, false, true, false, true and false. Now we are making use of AND. What is AND? The conjunction. So true into true gives you true. Again true, true gives you true. True, false gives you false. Like if there is one false, the entire term will be false. So all these contains F, 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 F. So this will be false, 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 false and false. Am I clear till here? Next it is negation of P and Q. So this will be opposite of this. This will be opposite of this. So it will be false, false, true, 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 true and true. Okay. Now what is that they are asking? We have to make use of this column and this column. What is that? The fifth column and then OR P. So we have to make use of these 2 columns. So what is that? It is OR. So true into false gives you true. False into false gives you false. And then you'll have true, all the truths. 1, 2, 3, 4, 5. Yeah. Why? What is the OR condition? If you have false, like if you have both false, then only you'll have false. Otherwise, the entire term will be true. So that is the reason you have to remember the key points. This is false and this is false. Now coming to the implication form. That is conjunction, I guess. Conditional, sorry. Implication is conditional. So what is the conditional? This is with respective to this one and with respective to negation P. Oh, we didn't do negation P. So we'll write over here, negation. I'm just writing the negation P over here. Negation P. So you'll have false, 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 false. You'll have true, 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 and true. So what is conditional? So this becomes true, true, false, false. Then the rest of the elements will be true, 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 true. Okay. So this is what our truth table is. Whenever if you miss some column, you can either write it at the right hand side or left hand side of your page. So this is what the truth table is. Okay. Shall we move on to the next one? The next question. I hope you are clear with all these things. The next question is, show that is asking P is biconditional to Q is equivalent to P implies Q and Q implies P. So if we directly write the columns, what will be the columns? You don't have to take negation over here because there is no negation P or negation Q in the question. So what are the columns that you are going to take? P, Q. The first one will be P biconditional to Q. And the next one will be P implies Q and Q implies P. And then you'll have P implies Q and Q implies P. Okay. So now what is the condition? As there are only P and Q, so you can take 2 trues and 2 false. True, 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 false, false, true, and false and false. So what is a biconditional? If you have 2 truths will be trues, rest of the elements will be false. And what is P implies Q? If you have first true and false, then the element is false. Otherwise, the rest of the things are true. Then what is Q implies P? Same thing. True, true, false, and true. Now we have to take AND condition between what and what, between this column and this column. So what is that? You'll have true, false, false, and true. So what is this equal? Is this column and this column equivalent to each other or not? So what do you think? Sorry, this is true. Biconditional, no? This is true. So what do you think? These are equal. P is biconditional to Q is equivalent to P implies Q and Q implies P. Okay? Now next we have definitions of derived conditions. Till now we just studied about connectives. Now we will study about derived connectives. Derived connectives. Okay. So the first definition is N and. N and. What were the, can you tell me what are the types of connectives that you had? What are the connectives that we had? Take out that line, Suresh. What are the connectives that we had? The first definition we studied was negation, and the second definition the second one was conjunction, and then you had disjunction, and then you had conditional, and then you had biconditional. Biconditional. Now we are going to study about derived connectives. Okay. In derived connectives, the first condition is N and. The first definition is N and. The second one is N or. The second one is N or. And the third one is X or. Okay. Now let us go into define the first definition, that is N and. Now, how will we define N and? The first is N and. Okay. So the negation of conjunction is defined as N and. I hope you remember the definition of conjunction. So the negation, N is the negation. Negation of conjunction, the negation of conjunction is defined as N and. Obviously, so this is denoted by P up arrow Q. Okay. What is they are telling it is the negation of conjunction, and it is denoted like this. You have to put an up arrow. It is called as conjunction. Okay. Now let's look into the truth table. You'll have P, Q, P and Q, and then you'll have negation of P and Q. What is conjunction? Conjunction is and. So negation of conjunction is this. Negation of conjunction is P and Q. So how is this defined? P up arrow Q. So write on the table true, 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 false, false, true, and false, false. So what is P and Q? You'll have true, false, false, false. So what is negation of this? False, true, true, true. So this is the negation of conjunction is this one. So N and table is this. That is whenever you have two truth values, then the statement will be false. The rest of the elements will be true. That is a key point of N and. Now coming to N or. If N and is negation of conjunction, what will N or be? N or will be the, now N or will be the negation of disjunction. That is, it is negation of disjunction. How is disjunction denoted as? It is denoted as or, and it is written like this, right? So this is defined, this is denoted like N or P, N or Q is given as the down arrow. Okay, now let's look into the truth table. You'll have P, Q, P or Q. Negation of P or Q is equivalent to P down arrow Q. So what will be the table? True, 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 false, false, true, false, false. So what is OR condition? If you have both false, false, otherwise the entire element is true. So what is equivalent? So negation of P or Q, negation of this. So false, 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 true. Okay, you just have to remember what is NOR. If two elements are false, then only it will be true. Otherwise, the rest of the statements will be false. This is NOR. Now coming to the definition of XOR. XOR is exclusively OR. Okay. We'll just look into this definition in the next class.